thermal fluid sciences experts. This is ProReadyEngineer.
Hello, this is Bassam Abdelnabi from ProReadyEngineer. I'm excited to share a new video series featuring industry cases. If you like what you see, please consider liking and subscribing. Take care and talk to you soon.
All right, let's jump right in. Today, we're going to break down a really cool case study on a huge and often overlooked challenge in high-tech industry: contamination control. It's a perfect example of how one tiny problem can snowball into a massive headache.
So this whole thing kicks off with an issue that's way more common and way more expensive than most people realize. In super sensitive environments like aerospace testing, the very air you're using can actually become the enemy, a silent killer of good, clean data.
So for this one aerospace client, an assessment turned up something pretty shocking. The compressed air line, the one meant to cool their incredibly sensitive optical instruments, was literally dripping oil. I mean, can you imagine? This wasn't just some minor leak. This was a red flag that their entire combustion testing operation was at risk. Okay, so let's really dig in here. Why is a little bit of oil such a catastrophe? Well, in the world of precision optics and high-stakes emissions testing, every single particle matters. You're looking at a triple threat. First, that oil was basically spray painting a film onto their expensive lenses, which totally messes with the data quality. Second, it was actually getting into the combustion process itself, skewing the emissions readings and threatening to invalidate entire very expensive tests. And finally, those oil deposits could create hotspots, putting the hardware itself under serious stress. A total mess.
Now you're probably thinking, okay, so just stick a filter on it, right? But it's not that simple. If you just slapped a single ultra-fine filter in that line, it would be like trying to stop a fire hose with a coffee filter. It would clog up almost immediately, leading to constant downtime and soaring costs. They needed a smarter solution.
And this is where things get really interesting. The approach wasn't just to sell a part. It was to engineer a complete system, something strategic, designed from the ground up for reliability and non-stop operation. The real genius here is this dual-branch manifold. You've got two parallel paths for the air to go through. The primary branch is the workhorse, doing all the heavy-duty filtration day-to-day. But, and this is the game changer, if that branch needs maintenance, you just switch over to the secondary branch live without ever having to stop the experiment. That built-in redundancy is huge for uptime. So, how does that primary branch actually get the air so incredibly clean? Well, it's not just one filter. It's a whole team of them working together in a very specific order. Think of it like this. The air first hits a coarse filter. This is like the bouncer at a club. It gets rid of all the big, obvious stuff like bulk oil and larger particles. Next up, a fine filter snags much smaller particles, all the way down to 0.1 microns. And finally, the air goes through an ultrafine stage that acts like a polisher, capturing any last wisps of oil aerosol. By staging it like this, you protect the most sensitive and expensive filters at the end, making them last way, way longer.
So the design is pretty slick, but what about the real-world results? This is where you see the true payoff, in uptime, in cost savings, and most importantly, in having absolute confidence in your data.
To take all the guesswork out of maintenance, they integrated these smart differential pressure monitors. As soon as the pressure drop across any filter hit 7 psi, it meant it was starting to get clogged, and it was time for a change. The system literally tells you when it needs service. No more reacting to problems, you're ahead of them. And the results of that smart design? They're just staggering. Look at this chart. A single filter would have been toast in under 500 hours. This multi-stage system, though, was designed to run for over 4,000 hours. That is an 8-fold increase in operational life. That's a dramatic drop in downtime and maintenance costs. For the client, this was absolutely transformative. They went from constantly putting out fires to proactively planning their maintenance. They got a real-time view into the health of their system. And the biggest one of all, they finally had total confidence that their air was clean and their test data was rock solid. When you really look at it, this whole case study highlights a core philosophy, a better way of thinking about how to solve these complex contamination challenges. It's about seeing the entire system, not just one broken part. See, the approach isn't to just sell a filter, it's to engineer a complete solution. It's all about finding that perfect balance between pristine air quality, long filter life, and maximum uptime. By thinking about all the downstream effects, you don't just solve one little problem, you protect the entire operational ecosystem.
And this leaves us with a really powerful final thought. The right engineering partner doesn't just protect a few parts or a piece of hardware. They protect the most valuable thing you have, the integrity of your work.